Hello everybody, in this video we're going to talk about how to find the inverse of a linear function. So really it's a three-step process. We know that if we have a linear function, it's going to start off most likely in function notation. So it's going to say f of x equals something. So probably f of x equals mx plus b, because that's our slope-intercept form, which is our main form that we're going to work with when graphing a linear function. So the step one just says set y equal to f of x. So instead of having f of x equals, we just want our equation to say y equals. Step two, we're going to switch x and y in our equation. So if we have y equals mx plus b, we want to change that to x equals ym plus b. Then we're going to solve the equation for y. So we're just going to perform inverse operations so that we can get back to y equals, and that equation will be our inverse equation. So let's do three of these. So we're going to find and graph the inverse of the function. So these three we have in this light orange color, and then the pen color that I'm using is kind of a turquoise-ish, greenish blue. So I'm going to do the work for the inverses in this turquoise color, and we'll graph those. And then I'll switch over to the orange color to graph the original function so we can see the difference between the two and what line they are symmetric about, okay? All right, so our first one is f of x equals 2x. So I'm going to start off by writing this as y equals 2x. Then we're going to switch x and y. Okay, now I want to solve this for y, so I'm going to divide both sides by 2, and my final equation would be y equals 1/2 x. Okay, so this would be y equals x divided by 2, which is the same as just 1/2 x. So now if I graph y equals 1/2 x, we have a y-intercept at the origin. I'm going to go up 1, right 2, up 1, right 2, up 1, right 2. And I'm going to do this as far as my graph can hold my points, just so it's easier for me to make my line. Okay, now we know there would be arrows at the end of those lines, so we'll go ahead and add those in. And now I'm going to switch over to my light orange gold color, and I'm going to graph this original function f of x equals 2x. So the y-intercept is still at 0, but now our slope is 2, so up 2 and right 1, or we could go down 2 and left 1. Okay, so now when we connect those, we can see our original function and our inverse. Okay, so now if we think about this line of symmetry that we have here, let's add that in. So all of these that we do, we should see that the original function and its inverse are symmetrical over this line that we see right here, which is y equals x. Okay, so that's always a good way to check to make sure. For your linear function, make sure that the two functions are symmetrical over that line, or it looks like you could fold them over that dashed line that I have there. That means we've done it correctly, okay? All right, let's look at b. f of x equals 1/3 x minus 2. So I'm going to start off by writing this as y equals 1/3 x minus 2. And now we're going to switch x and y. So x equals 1/3 y minus 2. And now we're going to solve for y. So let's add 2 to both sides. So now we have x plus 2 equals 1/3 y. And I'm going to multiply both sides by 3 so that I can get y by itself. So now I have y equals, and we need to make sure we distribute this 3, so that'd be 3x plus 6. Okay, so that's 3 times x and 3 times 2. So now 3x plus 6, 1, 2, 3, 4, 5, 6. Our y-intercept would be all the way up here. And our slope is 3. So I can't go up 3 because I don't have any more graph, but I can go down 3. 1, 2, 3. If I go down, I need to go left. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. Okay, so this is my inverse of my original function. And we'll switch over to our gold color and graph our original. So 1/3 x minus 2. So minus 2 is here. And 1/3 would be up 1, right 1, 2, 3. Up 1, 1, 2, 3, or down 1, left 3. All right, so now once we draw our line here, we should be able to check again to make sure these two lines are symmetrical over this line right here, which is y equals x. And it looks good, right? So we'll change that to our dashed line. And once again, that is y equals x. Okay, so it looks like we could fold those two lines over that axis of symmetry there, and we are good to go. We've graphed its inverse, okay? All right, last example, f of x equals negative 2x plus 6. So let's write this as y equals negative 2x plus 6. And let's switch x and y. Okay, let's go ahead and subtract 6 so that we can begin solving this equation for y. So now we need to divide both sides by negative 2. And this is going to give me y equals, now this is x minus 6 over negative 2, so that's like x divided by negative 2. So that would be negative 1/2 x, and then negative 6 divided by negative 2, so that would actually be a positive 3. I was going to say plus 3. That would be a positive 3. Okay, so now let's go ahead and graph in our turquoise color our inverse function. So positive 1, 2, 3 would be our y-intercept, and our slope is negative 1/2. So we want to go down 1 and right 2, down 1 and right 2, down 1 and right 2. Or we could go up 1 and left 2. All right, so let's make our line here, put our arrows at the end. Now let's switch over to our gold. All right, and we have f of x equals negative 2x plus 6. So we put our y-intercept at 6, and our slope is negative 2. So let's go down 2 and right 1. Down 2, right 1, 1, 2, 1, 1, 2, 1. A couple more here. And there we go. All right, so now when we draw our line here, that looks good. Put our arrows at the end. And now we can add in that red line, which is our axis of symmetry. And once again, that is the equation y equals x. So we make this our dashed line. And we can write our equation y equals x. Okay, and now, so once again, when we look at that, it looks like we could fold those two graphs over that dashed line, and so we know we have done this correctly, okay? And that's how you find the inverse of a linear function.